What you say then is very simple. We've set up a machine, a great computing machine, which has a random wheel in it that makes a succession of guesses. And each time it guesses a hypothesis about how nature should work, computes immediately the consequences and makes a comparison to a list of experimental results that it has at the other end. In other words, guessing is a dumb man's job. Actually, it's quite the opposite, and I will try to explain why. The first problem is how to start. You see, I'll start with all the known principles, but the principles that are all known are inconsistent with each other. So something has to be removed. So we get a lot of letters from people. We're always getting letters from people who are insisting that we ought to make holes in our guesses as follows. You see, you make a hole to make room for a new guess. Somebody says to you, people always say space is continuous, but how do you know when you get to a small enough dimension that there really are enough points in between? It isn't just a lot of dots separated by little distances. Or they say, you know those quantum mechanical amplitudes that you told me about, they're so complicated and absurd. What makes you think those are right? Maybe they aren't right. I get a lot of letters with such content, but I must say that such remarks are perfectly obvious and are perfectly clear to anybody who's working on this problem, and it doesn't do any good to point this out. The problem is not what might be wrong, but what might be substituted precisely in place of it. If you say anything precise, for example, in the case of a continuous space, suppose the precise proposition is that space really consists of a series of dots only, and the space between them doesn't mean anything, and the dots are in a cubic array.